Okay, so hello everyone. Our project is basically about the convergence of expectation maximization algorithm for the Gaussian mixture models. So basically, we know about the normal standard expectation maximization algorithm, and it's used for Gaussian mixture model fitting, and we know it's dependent on the amount of overlap among the mixture components. So in this project we're going to discuss about two new kind of algorithm which basic is based on the expectation maximization algorithm only, but we want to test it on three different data sets, and we're going to see that how these are better than the original or if it's better or not. So in our standard expectation maximum algorithm, we know that we have one expectation term, and in the maximization step, we always want to maximize it and keep iterating it and updating the parameter till we get the required result. So here for these three algorithms, this is our standard one, and these two our modified one. Our maximization step remains the same. The only change in it the expectation term. So you can see the standard expectation maximization algorithm. Our expectation value is this: alpha j p of xt given mu I comma sigma j upon sigma of alpha I p xt comma mu j sigma j. But in our this two algorithm, first is our DAEM, which is known as deterministic anti-annealing algorithm. Here we just add a exponent of beta basically into our term so that it will be might be more converging, or it the rate of convergence is slightly faster. So we're gonna see that via the graphical plots analysis using different data sets. And the final one is our modified DAM algorithm, where we also add a alpha j component in the exponent when alpha j is based on the jth cluster of this data set. So our solution approach flowchart will be like this. We have our data set. We will initialize our weight, means, and covariance randomly, and our initializing beta for our anti-annealing expectation maximization algorithm. For the second one, we are not thinking about the alpha j term as of now. So first we apply our expectation step. We, as you can see, we give our responsibilities based on GMM parameters and responsibilities using beta. Then we will proceed with our maximization step. It's similar kind of update the parameters, and then we take the log likelihood of it and check the convergence as we are doing it numerically with applying the code. So we check for convergence when the log likelihood change is less than a tolerance, and till it's not converged we can keep continuing the iterations, and after that we'll store the log likelihood, and we can compare the standard versus the new one which we are using on these three different data sets, and we can just adjust our beta for this. So you can see for the first data set we have our two clusters. You can see the plot, feature 1 and feature 2. It's a synthetic 2D Gaussian mixture model with 500 samples. So you can see they are classified into two classes, and we can on the right hand side we can also see the results for the both standard expectation maximization algorithm and our anti-annealing expectation maximum algorithm, which in which we gave the power exponent of beta. So we can see that the deterministic anti-annealing expectation maximization algorithm gives faster convergence than the standard one. We can also know the result for the this kind of result is cause of that beta exponent. So that's for the generated data set which we generated. Now we will analyze this same thing for these two data sets. First one is our wine data set. So you can see there are classified into three classes: wine type 1, wine type 2, and wine type 3. And here also you can see the results that standard expectation maximization algorithm gets stuck at a local maxima, whereas our DAEM algorithm is able to overcome the local maxima and it converges towards the global maxima. So you can see here the standard expectation maximization algorithm's drawback. So for the next one, iris datasets, we will use all three algorithms: our standard one, our DAEM, and our modified DAEM. So here you can see this contains 150 samples from three species. Here also there are three classes, and we can see from the graph the same problem arises here also. The standard EM algorithms get stuck at a local maxima, but our both DAEM and modified DAEM keep on converging towards the global maxima. What's the difference between the DAEM and modified DAEM? Which modified DAEM is a lot faster because of that alpha j component in the power. So the conclusion is our in the tabular form. Our for these three datasets, we have standard anti-annealing and modified anti-annealing. We have our ARI and NMI value for all these three, and you can see our modified anti-annealing expectation maximum algorithm for iris performed much better than those of two. And in the previous two datasets also, we can see that anti-annealing expectation maximization algorithm is giving the better results of the that of the standard one. So here are our references, you can see, and now we can look upon the code.